Should we just review what we've done for the video? Or should we? Let's just keep going where we're at.
Yeah, we'll just keep going because we'll do that little review right before we went.
And maybe they'll come in and we'll have to review it anyways.
Yeah.
Okay, so 7. What would happen to the width of the confidence interval if Gina increased the sample size? So it's going to be divided by a bigger number. So it should go down, right?
Mm-hmm.
Okay. And then what would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? Well, it increase because it's a bigger number.
Yeah, because it's increasing your Z.
Yeah.
Or what you're multiplying everything with.
Okay, Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Okay.
I remember that one was really fun to figure out.
So let's put down everything that we do know. We know.
So we know that we'll be using the margin of error formula.
Yeah.
Right. Which is normally M equals sigma blah blah blah.
2 times sigma divided by square root of n, right? For the margin of error formula.
Well, it won't always be 2. In the formula, it's actually Z.
Oh, yeah.
And in the
sorry.
example, I used 2.
Bad handwriting.
I did the same thing when I wrote it down the first time because that's what was in the book. They were using 2 as an example, but later on, it showed that it's supposed to be Z.
Oh, okay. That's probably why I wrote down 2.
Yeah, so I had to go back and change it, but it's Z sigma square root n.
Okay, so we have the sigma, which is 400, and we don't have the n.
Mm-hmm. We're trying to find n, but we do have a margin of error, which is 50 hours.
And we have, okay, we have 50 hours for margin of error. 50, and then we have the z-score too, which is 95%. So that's 1.96, right? Or was that 95? 1.96, yeah. 0.96.
We have the Z sigma and margin of error, so we just have to rearrange it to solve for n.
So then we would multiply by the square root of n. Multiply by the square root of n. And then do we
so the way it ends up looking is n equals Z sigma divided by m squared. Because they also gave us this formula in the reading. Because I think you'd have to square, wouldn't you, first? To get rid of your square root on the bottom and then multiply by n to isolate it. Do both sides by it. And then you would just move the 50 over.
But it'd be more than 50, wouldn't it? Because it'd be squared.
Well, you'll move it into your equation and square the whole equation.
Okay, but it already gave us the formula that it would be in the book. Okay, let's just stick with that. That'll make it easier.
Which would just be n equals Z sigma divided by m squared.
Z sigma divided by m squared.
Which for this part is 1.96 times 400 divided by 50.
400 divided by 50. But that 50 is squared, right? Because it's m squared.
It's not double squared. At least not that I saw in the book or 3.
Okay.
So let's see, we want M to equal 50, right? So we would take the square root of that, right? We'd do 1.96 times 100 divided by the square root of 15.68.
So they need 16 people.
Mhm.
I think it was like this before with the square root here, and then that cancels and that cancels, right? So then it's just that. Okay.
Well, then you have to move the z back.
Yeah. Okay. So that makes sense. The mean salary of actuaries is $100,000, and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance of 0.05, and the null equals 100,000, alternative does not equal 100,000. You collect a simple random sample of n equals 36 women's salaries and find that x bar equals 111,000. What is the lower limit of this 95% confidence interval? Okay, so we would take $100,000 minus 95, 1.96, and then we would do blank. Okay, 36,730 divided by 30. Okay, divided by 6. Okay.
Okay, I see how we do it. Yeah, so you don't have to square it down for the first one, because they brought the square root out of the whole and then moved the n and then squared everything.
Yeah.
So
Okay.
16 should be right.
Now for 10, did you get 88,001. Oh wait, 88. That one's the nearest whole number. So 88,002. Is that what you got?
No,
Oh,
for the lower limit.
yeah. What did you do for that one?
know. I have it set up.
I took
Save
100.
Zoom.
Oh wait. Oh, you used the 11,000 number. I
Yeah, the
used
X bar.
100.
Oh, you're using Mu.
Oh, okay. So I did it wrong.
So
3 minus 1.96, 36 divided by 6. Okay, 99,001 or 99,002. Is that what you got?
got 110,988.002. Let's see. So I did 111,000 minus 1.96 times 36,730 divided by the square root of 6. Yours is right.
Huh. I wonder
if I forgot that decimal the first time. Because it's X bar,
X
111,000 minus Z, which we're using 95%, so that's 1.96 times sigma, 36,730, divided by the square root of n.
So yeah,
Right there.
we did it right.
Square root of that.
Yeah. Okay.
So the first time I must have just forgot the decimal.
So 99002. So that's the same thing. Plus 1.96 and divided by 36,730 divided by 6. I got 122,998.46. And we round to the nearest whole number, so it's
122,998.
122,999. Okay. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are all of the above.
Mm-hmm.
Okay. And let's just go over everything real quick.
So here, participated.
Find the margin of error, 90% confidence interval. I got 20.
19.6.
So you take, was that, what confidence interval was that?
90.
So you take 1.6
times 50 divided by 25.
50. Yeah,
16.45. So 16.450. Just to get that third.
So we both had that weird. Okay.
This is why we check.
Yeah, exactly. Okay. 4 X bar is the point estimator of mu. 5 498.315. 6 553.685. It would decrease because it's dividing by a bigger number, and it would increase because it's multiplying by a bigger number.
16. 99002.
122999. I'll submit first.
All the above. Already.
All right. Let's see. 100%, please. Oh no, we got one wrong.
Who was the last one?
16. Okay. Standard deviation.
Okay, so what sample size do they need?
I need my calculator for my test.
Okay.
Even if it sounds like cool.
No, we'll be okay. I have one if you need one.
Damn it, this one.
Good luck.
Okay, so what sample size do they need? That was n time equals. What was there, Z? 95% confidence level, right?
Yeah.
0.96 times 400 divided by square root of the margin. Oh no, divided by just the margin, right?
Yeah, so we do 1.96.
Yeah, 15.68.
Plus 50. Okay. So we would do that. Can I see your calculator?
No, we didn't do.
What?
What I didn't do, I did square.
So the 1250. Just square 50.
No, you need to square the whole thing.
Oh, okay. So 246.
Very large number though. So let's put that back into the regular margin of error, which would be 1.96 times 400 divided by the square root of 246.
Okay. Yeah.
That big of a number, so 246.
I guess we probably should plug that in. So
Was that the only one?
I think so. Let's see here. Yep.
Yeah. And it's 246.
Okay, do we want to do the homework too? Do you have time to do the homework too?
Yeah.
Okay, let's do it.